Assalamu alaikum. I'm Mahpara from SRM Welkin. Today I'm going to discuss with you the discovery of electrons from the topic structure of atom that belongs to class 11 chemistry. In this, we will first recapitulate the Dalton's atomic theory. What are the drawbacks of the Dalton's atomic theory? What led to the discovery of subatomic particles, and finally we are going to discuss in detail about discovery of electrons. First, we will recapitulate the Dalton's atomic theory. Dalton started his teaching career at the age of 12, and it was in the year 1808 Dalton put forward his theory, which is known as the Dalton's atomic theory. The postulates of the Dalton's atomic theory are like the ultimate particle of the matter is atom, which is indivisible and indestructible. The atoms of the same element will be identical in each and every respect like mass, valency, etc. While as atoms of the different elements differ from one another in mass, valencies and other chemical properties as well. The compound is formed by the combination of two or more than two elements which combine in a fixed ratio by mass. Dalton's theory was successful in explaining the laws of the chemical combination like law of conservation of mass, which states that atom can neither be created nor destroyed during any physical or chemical change. That is also one of the postulates of the Dalton's atomic theory, and the law of definite composition, that compound is formed from the different elements when they are combined with one another in a fixed ratio by mass. So Dalton was able to explain the laws of the chemical combinations. Now, what are the drawbacks of the Dalton's atomic theory? Dalton was not able to explain why certain materials like glass or ebonite rod gets charged on being rubbed with silk or fur. So Dalton was not able to explain the electrical nature of the matter. According to Dalton, atoms are indivisible, but we know nowadays that atom is no longer considered to be indivisible because of the discovery of various scientists like Rutherford, Neil Bohr and other scientists. We know that atom is made up of further smaller particles, and those smaller particles are known as the subatomic particles, and these subatomic particles are electrons, neutrons and protons. Now in this we will discuss about the discovery of electrons. The electrons were discovered by carrying out an experiment, and that's known as the discharge tube experiment. It consists of the long glass tube as is shown in the middle, and this tube is filled with the gas and it is fitted with two electrodes. One of the electrode is attached to the negative of the battery and is negatively charged, known as the cathode, as is shown in the figure. Other electrode is attached to the positive of the battery and it acquires the positive charge and is known as the anode. So this tube consists of the gas in it and is fitted with these two electrodes, cathode and the anode. Further, to this tube, vacuum pump is attached. Now the question arises, why do we require a vacuum pump over there? Because the gas present in this, it has been found that gases under ordinary conditions act as the bad conductors of electricity. But In the presence of low pressure and at very high voltage, they act as the good conductors of electricity. So vacuum pump is used there in order to maintain the pressure of the gas so that they act as the good conductors of electricity. And also the electrodes are attached to the high voltage source nearly about 10 to the power 3 volts. Now some kind of rays are coming out of the cathode which have been called as the cathode rays. As they are coming from the cathode electrode, that's why they have been given the name cathode rays. Further, this glass tube is also known as the Crookes tube. It's because this experiment was first of all carried by the William Crookes. That's why this tube is also sometimes known as the Crookes tube. And this is the construction, or we can say the different parts of this discharge tube experiment. So from the discharge tube experiment, we come to know that some kind of rays are emerging from the cathode and they are known as the cathode rays. Now here we are going to discuss about the properties of these rays known as the cathode rays. It has been found that some kind of rays coming from the cathode are we can say they come from the cathode and flow towards the anode in straight lines. But how we get to know that they travel in the form of the straight lines? When an opaque object was placed in between the cathode and the anode, opaque object is such a kind of object which does not allow the light to pass through it. So what happens when that object was placed in the path of the light, the shadow of that very object was formed on the wall opposite to the cathode. That gives an indication that the rays coming from the cathode or we can say they travel in the straight lines from cathode towards the anode. Further, the rays which were coming out of the cathode are invisible. We cannot see them as such. So how they were detected? Actually, we know that we have some kind of materials which are known as the fluorescent materials. Fluorescent materials are those materials when they are being hit by such kind of radiations, they produce some bright spots. They produce some kind of glow. That's why they are known as the fluorescent or the phosphorescent materials. So what was done? The side of the anode tube, or we can say the discharge tube from the anode side, was coated with the zinc sulfide screen. And what happened? The rays which were coming from the cathode and further the anode was made perforated. So what happens from this? When the rays were coming from the cathode, they passed through the anode, they passed as such through the anode and they strike the zinc sulfide screen and they produce bright spots over there, which gives an indication that these are the rays which are coming from the cathode. That's why we are able to detect these rays which were coming from cathode towards the anode. As I have written in the first property that the rays will travel from cathode to anode in straight lines unless and until they will not be influenced by any kind of electric or magnetic field. It's because it has been found that if they are influenced by the electric or magnetic field, they show some kind of deflection. That means they must carry some kind of charge. That's why they are showing some kind of the deflection. In the second figure, you may see that if the discharge tube is subjected to the electric field, or we can say electric field is just the combination of two plates, one carrying the positive charge and another carrying the negative charge. When these plates are placed near these rays which were coming from cathode to the anode, what happens? These rays which were coming from the cathode, they were showing some kind of the deflection, and that deflection was shown towards the positive plate, which shows that, because we know unlike charges attract and like charges repel, if these rays are being attracted towards the positive plate, that means, or we can say if they are deflected towards the positive plate, that means they must have the charge opposite to that of the positive plate. That's why they are being deflected towards the positive plate. This shows that they carry negative charge. So, the rays coming from the cathode to the anode are negatively charged. That's why they are being attracted by the anode. So these were the some properties of the cathode rays. That's they travel in straight lines, they form the shadow of the object if that's placed in their way between, and they become visible only by placing there some kind of the fluorescent material, and they carry the negative charge. Now what we can further say that, we can say that if the we can say the electrode material as well as these gases were exchanged, it was found that the properties of the cathode rays were found to be independent, that all the properties remain same whatever will be the nature of the electrode material or the nature of the gas. Now the question may arise, why on changing the nature of the gas or the electrode material, the properties of the cathode rays should get changed? It's because the gas is present at low pressure but gaseous molecules are present there. When the ray or the cathode ray coming from the electrode strikes this gaseous molecule, it may the energy of the ray may be sufficient to ionize that gaseous molecule and to knock out some fundamental particle, and that will be attracted by the anode. So on changing the nature of the gas, that process remains the same. Similarly, on changing the nature of the electrode, the same process where happens. This shows that there is some fundamental, these cathode rays are some kind of fundamental particles which are present in every kind of the atom. That's why they are, we can say, remain unchanged by changing the electrode material or the nature of the gas. So from this we can conclude that the electrons, these are the electrons which act as the basic constituents of all the atoms, and we are going to discuss about the other properties of the electrons in the next lecture. Thank you.